Zeal Education Society, redefining excellence.
Hello everyone, this is Prashant Gaikwad with Zeal Polytechnic studying in third year mechanical. Today we are going to discuss about construction and working of hydraulic press used in fabrication shop. This project was done under the guidance of Professor E.S. Mehta Madam. The project members were Shrikant Yadav, Vikrant Sangre, Rakesh Sovatkar. In the project, we have introduction, objective and literature review, design approach, manufacturing process, and the conclusion. Introduction. A hydraulic press is a device using a hydraulic cylinder to generate a compressive force. It is also known as Brahma press after the inventor Joseph Brahma of England. He invented and was issued a patent on this press in 1975. Frame, hydraulic cylinder, and press table are the main components of the hydraulic press. Hence, a hydraulic press is a machine that makes use of the pressure exerted on the fluids to crush, straighten, or mold. The concept of hydraulic press is based on Pascal's theory, which states that when pressure is applied on fluids in an enclosed system, the pressure throughout the system always remains constant. In hydraulic press, the force generation, transmission, and amplification are achieved using under pressure. The liquid system exhibits the characteristics of a solid and provides a very positive and rigid medium of power transmission and amplification. In simple application, a smaller piston transfers fluid under high pressure to a cylinder having a larger portion areas, thus amplifying the force. There is easy transmissibility of large amount of energy with practically unlimited force of amplification. Objective and literature review. Using the optimum resource possible in designing the hydraulic press, components can effect reduction in the cost by optimizing the weight of material utilized for building the structure. An attempt has been made in this direction to reduce the volume of material, cost of the press, and to make it portable. ERTL et al. Presented a 2D nonlinear magneto-mechanical analysis of an electromagnetic actuator based on finite elements. The presented method enables the simulation of the complete switching cycle of a switching short stroke solenoid actuator with sufficient accuracy. This could be achieved by considering nonlinear magnetics, eddy current induction, and a physical correct implementation of the contact mechanics, which are relevant for the complex dynamics of these valve types, combining the concept of pre-magnetization as well as over-excitation to optimize the actuator dynamics. The pure valve needle flight time at valve opening can be reduced to 200 ms. The developed numerical tools enable a systematic study of several methods to optimize the dynamics. Presented a model of a fast 2x2 switching valve where both the magnetic paths as well as full assembly are modeled. The model also includes a description of the hysteresis characteristics of the magnetic path. Working principle. A hydraulic press is a machine that uses pressurized liquid to create force. These machines are composed of a simple cylinder and piston mechanism. The press consists of a large cylinder with a large piston and a small cylinder and a small piston. The large cylinder and the small cylinder are connected to one another by means of a pipe. The two cylinders and the pipe connecting them are filled with the liquid. At this point, the function of the hydraulic press depends on Pascal's principle. Pascal's principle states that when pressure is added to a liquid at rest, there is an identical increase in pressure at all points. Applying this principle to the hydraulic press means that any force that is added to the piston in the smaller cylinder will be transferred to the piston in the larger cylinder is proportionally increased level of forces. Model of hydraulic press. Since the hydraulic press works on the basis of Pascal's law, its working is similar to one of the hydraulic system. Hydraulic press consists of basic components used in a hydraulic system that includes the cylinder, piston, hydraulic pipes, and etc. The working of this press is very simple. The system comprises of two cylinders. The fluid is poured in the cylinder having a small diameter. The cylinder is known as the slave cylinder. Table includes details of all components required for building the actual model of hydraulic press. The details of components is given in the below table. Base is made up of mild steel, movable plate, mild steel. Spring is also made up of mild steel. Upper plate is also made up of mild steel. Jack, mild steel. Body, cast iron. Die, mild steel. Punch, mild steel. And the frame of the machine is of mild steel. These are the specifications of the hydraulic press shown in the figure. Height is 725 mm, width is 380 mm, C channel is 72 into 40 mm, spring elastic type, number of quantity 2, free length 230 mm. Jack used in this press is the capacity of 10 tons, the height is 300 mm. Hydraulic presses are available in many types of construction, which is also true of mechanical presses. Following construction details just gives the basic idea of dimension of different parts used in the design module. Base is manufactured from 75 into 40 mm to C channel of length 380 mm welded together. The height can be adjusted using rods. The die used for the particular given shape is welded at the bottom plate. The dimensions of the frame is 725 into 380 mm of C channel of 775 into 40 mm with two support of C channel. Spring having free length 230 mm is fixed between middle plate and frame so as to get the flexible movement of the movable plate. Punch is welded at the bottom of the movable plate. Jack is mounted in between the frame and middle plate. The basic manufacturing process is shown in the below figure. It is a multi-purpose machine as it can be used for performing different tasks. By changing the die, different operating like bending, blanking can be performed on a hydraulic press machine. The design has main focus on reducing operative fatigue and increased safety, improving the flexibility and makes operation more convenient. To achieve dimensional and positional accuracy, components of press are designed to avoid bending failure due to applied load. Mild steel is selected as material based on its properties such as high bending and tensile strength. Its compatibility with operations like machining, welding, finishing, cutting, and cost as an economic factor. Thank you.
Zeal Education Society, redefining excellence.